Hello out there, welcome to this tutorial on matrices. In this video, we'll be looking at some miscellaneous problems. If you are joining us now, check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on matrices and determinants. So we start with the first problem. Problem 1. Given that A is equal to 2 negative 1, 3, 4, evaluate A squared plus 3A minus 2I, where I is a 2 by 2 identity matrix. So we start with the solution of this problem. First, we evaluate A squared. So A squared means A times A. In this multiplication, this is 2 by 2 matrices, so the multiplication is conformable and we are going to have 2 by 2 matrix as our product. So we have our brackets, then we are going to be multiplying row by column, so that for the first element we pick the first row and multiply it by the first column. So we multiply and add the corresponding entries. So 2 times 2 gives 4 and negative 1 times 3 gives negative 3, and that will be added to 4. Then for the second entry in the first row, we now multiply the first row by the second column. Multiplying the corresponding element, 2 times negative 1 gives negative 2, negative 1 times 4 gives negative 4, and it is added to negative 2. So we are done with that. For the second row, we are going to pick the second row of the first matrix and multiply it by the first column to get the first entry in the second row. So we pick this, multiply by this column. Multiplying the corresponding element, 3 times 2 gives 6 and 4 times 3 gives 12. So that will be added to 6. Then we are done with that. We still maintain this second row and then multiply it by the second column to get the second entry in the product. So multiplying the corresponding entries, 3 times negative 1 gives negative 3 and 4 times 4 gives 16. So that will be added to negative 3. We then go ahead to simplify. 4 plus negative 3 is as good as saying 4 minus 3, since positive times negative gives negative. So 4 minus 3 gives 1. Then the second element, negative 2 plus negative 4 gives negative 6. Here is clear, that is 18. And here negative 3 plus 16 gives 13. And that's all for A squared. Then we go ahead to evaluate A squared plus 3A minus 2I. So we have our A squared already, then plus 3 multiplying by A, then the next thing is minus 2, then multiply by I. How do we get that? The principal axis are units, while elsewhere are zeros. So we have the first element here to be 1, then 0. Here we have 0 and then 1. If you look at this now, this is the principal diagonal or entry. So it is 1, 1, 1, and elsewhere you'll be having zeros. So we then simplify. We use this 3 to multiply every entry in the matrix. So we have plus 6, negative 3, 9, and 12. I have used this 3 to multiply every entry here to have this. Then this is minus. We are using this 2 to multiply every entry here. That's going to give us 2, 0, 0, 1. Then we simplify. So the first element, 1 plus 6 is 7 minus 2. That's giving us a 5. So I have 5 there. Then we go to the second element in the first row. Negative 6 plus negative 3 gives negative 9. Then minus 0 is still giving us negative 9. So we have it as negative 9 there. Then the first entry in the second row, we have 18 plus 9 minus 0 will still give us 27. Then 13 plus 12 gives 25. Then minus 2 gives 23. So this is the end of solution to problem 1. So we go to problem 2. For problem 2, given that P equals 3, negative 5, 0, negative 2, and Q equals x, negative 4, 5, 2y, find the value of x and of y for which A, 3P minus 2Q is equal to 5, negative 7, negative 10, negative 2. B, P plus 4Q minus 3I equals 4, negative 21, 20, negative 23, where I is a 2 by 2 identity matrix. So from our solution, we are starting from A, 3P minus 2Q. We have our 3, then we bring in P, then minus 2, we bring in Q. We simplify and compare our result with this matrix. So we are going to use this 3 to multiply every entry in P. So 3 times 3 gives 9, 3 times negative 5 gives negative 15, 3 times 0 gives 0, and 3 times negative 2 gives negative 6. Then here we are only using this 2 to multiply every entry in Q, since this minus is an operation. So we multiply out. So this is going to give us 2x, negative 8, 10, and 4y. Then we go further now to evaluate 9 minus 2x. That will give us 9 minus 2x. Negative 15 minus negative 8 will give us negative 7. 0 minus 10 will give us negative 10. Negative 6 minus 4y gives negative 6 minus 4y. Then we said we are going to compare these matrices. Comparing them, this minus 10 is equal to minus 10, minus 7 is equal to minus 7. So which means 5 is equal to this and negative 2 is equal to this. So we equate them accordingly and solve for the value of x and of y. So we say 9 minus 2x is equal to 5. You see this? The first element here is equal to the first element. So solving this, we have 2x is equal to 4, where x is equal to 2. Then we go further again. This is negative 6 minus 4y is equal to negative 2. Moving this to this side, we have 4y is equal to negative 4. This is negative 6 plus 2, which gives negative 4, and y is equal to negative 1. That is the end of solution to problem 2a. We then go to 2b. For b, we are to find the value of x and of y if p plus 4q minus 3i is equal to this. And we still remember our I is identity matrix of order 2. So we have p plus 4q minus 3i. We have our p here plus 4 multiplying by q, then minus 3 multiplied by I, which is the identity matrix of order 2. So simplifying these two, we have our p still coming in. We use this 4 to multiply every entry inside the matrix. So we are going to have 4x minus 16, 28y. Then also this is minus 3003. Then we add and subtract. So 3 plus 4x minus 3 will give us 4x, and minus 5 plus negative 16 minus 0 will give us negative 21. Here is 0 plus 20 minus 0, that will give us 20. Negative 2 plus 8y minus 3, that will give us 8y minus 5. So having gotten this, comparing this matrix and this, you see this 4 is equal to this 4x. You see negative 21 equals negative 21, 20, 20. So these will be equal to negative 23. So starting from x, 4x is equal to 4, where x is equal to 1. Then we have 8y minus 5 equals negative 23. So taking this to this side, I have 8y is equal to negative 18, because this becomes positive on getting here, and y is equal to negative 2.25 after dividing both sides by 8. And that is all for B and question 2. We then go to question 3. For question 3, given that m equals negative 3x 3 negative 2, find the value of x for which A, m is a singular matrix, B, determinant of m is equal to negative 3. In our solution, starting from A, determinant of m is going to be 0, since m is a singular matrix. So how do you find determinant? As if we are applying cross product rule, negative 3 times negative 2 gives 6, and 3 times x give x, then we take it away from 6. So we have 6 minus 3x is equal to 0. Then 3x is equal to 6, where x is equal to 2. And for B, we are told the determinant is negative 3. So this is the part that is the determinant. So we have it and equate it to negative 3. Then we have negative 3x is equal to negative 9. And x is equal to 3. And that's all for problem 3. And this is the highest we can take in this tutorial. I hope you enjoyed it. Please like and share this video. Remember to check the description section of this video on our YouTube channel to get the link to the playlist containing all the videos on matrices and determinants. Until we come your way again, goodbye.